Okay. I'm going to start with a quick introduction to the course. My name is Jennifer Bigus, Professor Jennifer Bigus, and I did put an introduction out on our introductions discussion board. I also talked probably a bit about myself yesterday in the office hours, so I won't bore you with all the details again today. What I'd like to talk about, though, is the actual Blackboard, and make sure you're finding everything you need in the Blackboard system. I know I went through some of this yesterday, but I'd like to go through it again just to make sure everybody is seeing what they should be seeing on the course website. So I'm going to actually share my Blackboard application so that you can see what I'm seeing. Okay, can everyone see that okay? Okay, so this is what my home page looks like. Yours may look a little bit different. And the first thing I want to point out to you that you may not have noticed is that there is something here that says Start Here. The Start Here, unfortunately, they put it near the end of all the links, but the Start Here is where you should have gone when you first started the course. This talks a little bit about what the technical requirements are for logging in, gives you some background, but what I wanted to point out to you is this link down here. Everyone see where it says Student Manual and Course Schedule? This student manual gives you a little bit of information about some of the policies for the course, and it also gives you the week-by-week course schedule. So you'll be able to see everything that will be covered week by week, what the reading assignments are, what the assignments are, and so forth. Okay, so it's basically the same thing that you will find in Blackboard under the weekly instructions, but it'll be all in one place in a PDF document that you could print out if you'd like to, or view online. Okay. The next thing I want to point out is the syllabus. Okay, you should take a look at this because, again, this gives you an overview of what's in the course, as well as it talks about the grading and how your points in the course will be distributed. Your assignments will be worth 20%. Your midterm exam will be worth 30%. Attendance and discussions will be worth 10%, and the final exam will be worth 40%. So the course is very heavily weighted toward the midterm and the final. But you are also graded for posting on the discussion board, doing the assignments, and attending this live session. All right, any questions so far? Okay, some of the other things I want to point out is the weekly instruction, which I believe everyone has seen so far, and here's where you'll find PowerPoints. I won't be going through those exact PowerPoints today because we don't have enough time to go through all of them, but I will be pulling PowerPoints, or I have pulled PowerPoint slides from those presentations to use in my presentation today. Hello, Nora. The reading assignments are listed. There are videos out there that you can watch. Your assignments for the week are listed there, and so forth. So this will be appearing, week by week throughout the course. I also want to make sure that you have the right version of the book. You should be able to go into the e-textbook and find the Operating Systems Concepts book. You must have the 9th edition International Student version, because that is what's going to match both the reading assignments and the exercises. So make sure when you read the textbook, even if you have other versions, read the textbook that's here online. So it is right in the course materials. Muna asked if I can upload my slides. I can send you my slides. I will not be doing that before the classroom session. However, I can do it after the session because I do ask questions during the session, and if I upload my slides, you'll know the answer before I ask the question. Okay? So I will send you these after the class today. Okay, discussions, you've probably already been out there, or some of you have. I want to just point out a few things. These are the two discussions, the week 1 class member introductions and the discussion exercise that are due this week. I see here that some people have posted since I've looked out here, and I do read each and every post that you put out here. You will be required to read other people's posts and respond to them as well. I also want to point out this discussion board, and this is week 1 questions and answers. This is for you to use for any question you might want to ask. It's often helpful if you ask questions that you posted here rather than emailing me, because then if other people have that question, they could go out here and find the answer. Also, sometimes you might have a question and I might not see it right away. One of your classmates can answer the question as well if they already know the answer. Hello, Hala. I see Michelle has also joined. I'm trying to keep track of everyone who's joined. I will ask you to stay on a minute at the end of the class so I can make sure my attendance is up to date so that you do get credit for being in the class today. I was talking a little bit about the question and answer again. Post your questions out here, although feel free to email me at any time with questions. If it's a question that I feel that more people may be interested in the answer to, I may post your question and my answer out on the discussion board myself, just so everyone can see it. Okay? You probably also noticed that I do send you emails of the announcements. Usually when I post an announcement, I send an email at the same time. This is something the system will do automatically for me. You will usually get an announcement on Saturday and sometime on Tuesday, probably in the evening your time. On Saturday, I will be reminding you of what you have due on Sunday, since most of our assignments are due on Sunday, as well as I will give you a preview for what we'll be talking about in the coming week. And then on Tuesday, I will also be sending you a reminder to come to this class session. I know everyone is busy. It's sometimes easy to forget that you have a meeting like this, so I will send you a reminder for that. Okay, but as I said, feel free to email me at any time. And I'll try to answer any questions that you may have. If I don't know the answer, for example, sometimes there are things having to do with Blackboard or how things are set up in the course that I don't have control over, I will try to get the answers for you or point you to someone who can answer the questions. So feel free to email me at any time. I do look at my emails throughout the day, okay, but it's my day, not yours, so there might be some delay. Since you are 8 hours ahead of me at this point, and at some point you're going to be 9 hours ahead of me in time. Okay. So let me get back to my Collaborate session. For some reason, it's not letting me get back to my Collaborate session. Let me try to get back here. Okay, so we should be back to the folder with the slides. Okay, any questions on anything so far? I do want to talk a little bit about grading. For an assignment to be considered on time, it needs to be submitted by 11:59 p.m. on the due date. If it's 1 second late, it's considered to be late. Okay, I have to use this as a strict cutoff because if I accept something that's 1 second late, then I need to accept something that's 5 seconds late, and pretty soon we're into the next day and people are still submitting things. So unless it's submitted by 11:59 p.m. on the due date, it will be considered late. When you submit an assignment on time, you will get up to 100% of the available points for that assignment. If you can't get it done in time, I do accept late assignments, but I only accept those up until the point that I've handed back the assignment to other students in the class, or we've talked about it in our virtual classroom session. Okay, but usually we don't talk about these too much in our virtual classroom session once they're already due. So usually you have 2 days to turn things in late because I usually try to get the assignments back to you within 2 days with the grade and feedback. So if you turn something in late, you will get up to 75% of the available points. In other words, there's a 25% penalty for turning it in late. So you have some things due on Sunday. If you get it in by Sunday at 11:59, you will get possibly full credit for it. If you turn it in by Tuesday, it'll be considered to be late. After Tuesday, other people will have received their assignments back, so you will no longer get any credit, even though I will still accept them up to a week after the due date. Sometimes you just don't get it done in time. I can't give you credit for it because other people have already gotten the solutions to the problems. I can't award you points for it, but I still will look at them if you send them to me to give you feedback. So if there's anything that you can learn from it, you can still do it even if you don't get credit for it in the course. If something comes up, and here I mean something serious like you are hospitalized, you are very sick, there's a family situation that comes up, please contact me before the due date passes. I can give exceptions to the late rule, but only if I know about the situation, if I know what's going on and I've granted you an exception. Okay, the exceptions are only for serious situations, not for bad planning. In other words, if you've had all week to do an assignment, if you wait until Sunday to do it and something happens on Sunday and you don't get it done, in my mind, that is bad planning because you've already had a week to do it. Okay, so do you see what I'm saying? I understand that things happen that you can't plan for, but by the same token, please try to plan and get things done early, or at least get it started early. Sometimes what happens is a student, just doesn't have time to finish it. They've started the assignment and an emergency situation comes up. Let me know. You can even send me what you have done so far, but say that you'd like to finish it once the emergency passes, and we can make arrangements at that time. Okay? So I tried to be somewhat flexible, although, I do have to adhere to the course due dates. Okay, any questions on the grading? I do have certain expectations in this course. Reading the textbook is your primary responsibility. It would be nice if you could get the reading done before we have our virtual class session, because we'll be talking about these things. I'll be going over them at a high level, but I won't be going through everything in detail like it does in the course book. But you are responsible for everything in the textbook. The exams will be based on the textbook reading. I am not making up the exam, so I don't even know exactly what's on it. The exams are made up by faculty at SEU, and they will be grading them as well. As far as your discussion boards and assignments, they should be submitted on or before the due date, and I do expect individual original work. What I mean by that is I don't want you to just copy what's in the textbook and send it to me. And I don't even mean literally copy and paste on the computer. But what happens sometimes is if you're asked a question and you start looking in the textbook for the answer because you don't remember it or you need to review, it was a while since you read that section of the textbook, sometimes even unintentionally, you just spout back what you read because it's fresh in your mind. And this happens to everyone. It's not something that, people are trying to cheat or anything like that. But what I learned when I was in grad school, somebody told me that a good thing to do is if you want to write about something that you've read it or review it, wait 15 minutes, a half hour, and then without looking back, write your response, write the text that you want to write. Then if you want to check back to see if you missed anything or you don't have something quite right, go ahead and check back in the textbook and fix it. But really try not to just give back to me what I've already read in the textbook. Try to give me your own thoughts. State things in your own words. Okay? So I just want you to be careful about that, especially as you get to the point where you're writing more papers, as you're doing things, say, in graduate school, and you might get things published in journals and so forth, which often happens when you're writing academic papers. What you may want to follow this rule about reading it, waiting, and then doing your writing, because copyright and plagiarism is a serious offense if you're found doing that, even unintentionally, when you submit something to a publication for review. So it's a good habit to get into. As far as what I expect, for the written assignments, there will be questions that you're asked. You're going to create a Word document. I assume everyone has access to Word, and the assignments will be emailed to me. What I expect for discussion boards, have a 3 to 5 sentence response. Okay, a 3 to 5 sentence response on a discussion board shows me that you've thought about whatever one of your classmates has posted, and it's more than just yeah or I agree or that type of thing. I'm looking for more of a thoughtful response on the discussion board. If you have any questions, whether what you're doing is enough, feel free to ask me. I'd be happy to look at your work and let you know how you're doing. Okay? My goal here is not to make you suffer or trick you in any way. My goal is to help you get through this course and to learn as much as you can from the course. Okay, our office hour meeting, which was yesterday, attendance for that is optional, and you will not be graded on the attendance for the office hours. That's primarily for your use. I go and I sit in the Blackboard Collaborate room and wait for people to show up and ask me questions. That's pretty much what I do during office hours. So it's really up to you whether you want to talk to me, have a discussion, whatever. The class meeting, which is what we're doing today, attendance is required, and that's why I want to make sure that I get everyone marked on my attendance sheet as we go here. The problem I have right now is that in our room here, you're listed in alphabetical order by your first name, and on my grading, you're listed by last name, and so it's hard for me while I'm doing the class to actually match them up. So I'll just need a minute or two. Okay, any questions on that? Okay, unfortunately, just going through this has taken a lot of our time, but I did want to make sure that you all were familiar with what was expected and so forth. As far as your assignments for the week, introduce yourself on the discussion board. If you haven't done it, do it today, okay? It's important that we get to know each other. Some of you already know each other, but I'd like to start building a community of learners as we go through the course together, and one way to do that is we get to know each other a little bit. You're also required to respond to 2 other class member postings, and you can do this by Sunday. Our other assignments for the week is a discussion exercise where you're supposed to summarize your thoughts on what is an operating system. You should get that out on the discussion board by Thursday. So that gives your classmates time to read it and respond, and your response is due by Sunday. So your initial posting is due by Thursday, your response is due by Sunday. And again, here I'm looking for just a short paragraph, 3 sentences, 5 sentences in response to at least one of your classmates. Any questions? Okay, well now I'd like to get into the actual information that's in your course, and this is in your student guide and in your weekly instruction what the learning outcomes are for the course. You should be able to describe the major components of an operating system, describe the services that an operating system provides, and discuss the various ways of structuring an operating system. And these are pretty much the topics that are covered in the first 2 chapters of your book. So can anyone tell me, and just post it on in the chat room, what do you think are the 3 main purposes of an operating system? If you can only think of one, just tell me that one. But what do you think the 3 main purposes are? You don't need to raise your hand, just post it into the chat session. This way we can kind of get everybody's thoughts. Oh, I'm sorry, I missed a question. Someone had asked there's no face-to-face in this course. That is correct. There are no face-to-face meetings in the course. Okay, Hala, you asked a question, the dead date starting from today. I'm not sure what that means. For this week, since we're kind of, just getting started, try to get everything done by Sunday. If you haven't already posted your introduction, try to get it done today. Get everything done as soon as you can. I'll be a little lenient in this first week because I know we're getting started. Okay, some of the responses here that I'm seeing is running programs, having control, managing the computer tasks, control and coordinate, execute user programs, control the resources. Okay, so you all have quite a few good ideas about what an operating system is. Basically, the operating system has three main purposes. It's to provide an environment for a computer user to execute programs, and a lot of you pointed that out already. It's also meant to allocate resources, and a lot of you noticed that as well. You want the computer to allocate resources to solve the problem that you're trying to solve, because that's basically what computers are for. They're there to solve problems. And then finally, some of you mentioned control. It's a control program that supervises the execution of the user's programs, and it also manages the operation and the control of the I/O devices. Okay, so I think you all have a great idea on what an operating system is and what its purpose is. And we're also discussing that out on our discussion board. So the operating system's goals are to execute user programs to make solving problems easier, to make the computer system convenient to use, and to use the hardware in an efficient manner. Okay, and this isn't so easy to do. Different users have different needs, different wants. So, what's easy for one person might not be easy for another person. What's useful is different depending on the user. Okay, what's convenient is different depending on the user. And then sometimes there are conflicts between making it efficient versus making it easy to use. For example, in a computer system, in the old days, everything had to be done through the command line interface, or even in the very old days, you had to punch things into punch cards, and that wasn't easy or convenient for the user. But today, we do things with GUIs, with touch screens. That's much easier and more efficient, but it takes more hardware. It takes more memory. It takes more CPU power. Okay? So sometimes these things are in conflict. As far as making programs easy to use, I always like this quote. I don't know if you know who Bjorn Strustrup is, but he's the creator of the C++ language. And he had said, "I have always wished for my computer to be as easy to use as my telephone. My wish has come true because I can no longer figure out how to use my telephone." Okay, he's pointing out how in today's world, our telephones are little computers that we carry around with us and we use all the time. And I know, like, for my mother, she has a very hard time using a cell phone other than to make phone calls. She doesn't text message, she doesn't keep her calendar on there, she doesn't do any of those things. All she does is phone calls, and she can't even figure out how to get her voicemail. So it's very different today and what we're all used to with technology than it was many years ago. So our computer systems have gotten more and more complicated, and they've gotten smaller and smaller, where now we carry a smartphone around with us everywhere we go. Most of us do anyway. And we're carrying around a computer that is many, many, many more times powerful, more complicated than the computers I used back in 1970s when I first was starting to learn how to program. Basically, if we look at a computer system, though, they all look pretty much like this. Even our smartphones. We might not have compilers and text editors, although we do have notepads and so forth on our smartphones. But we have a lot of this on our phones as well as on our mainframe systems. So there are basically 4 different components of a computer system. I'm going to start at the bottom here and talk first about the computer hardware, which you might know is your CPU, your memory, your I/O resources, okay? And that's part of a computer system. On top of that, you'll see the operating system. And most of what we're going to talk about in this course is the operating system, and you're starting to read a lot about how it's a resource allocator, how it's a control program, how it controls and coordinates the hardware for the applications and the users, how there's a kernel that's always running. And we're bombarded with all this information. I'm sorry, I forgot to click on the pointer. It is there. We're bombarded with all this information about what is in an operating system, and then I ask you a question like, what is an operating system? And there's really no good definition that I can say, yes, you have it 100% right, because it varies from computer to computer, from vendor to vendor. Some people define an operating system as what you get when you order one. Other people look at it as just the very bare bones control of the system. Okay? On top of the operating system will be your system and application programs. Some of these are shipped with your operating system. You get them on your phone and so forth. And then the reason for all this is us, the user. The whole reason for computer systems is to solve problems for the user. Okay? Unfortunately, computers aren't always easy to use, even though they're meant to be something that makes our lives easier. So your book talks a little bit about computer systems and how they're booted. There's a bootstrap program on the EEPROM, and that loads the operating system and so forth. Once you're there, once you're sitting at the user interface, how does a user or a device or a piece of software let the CPU know that an event has occurred? Okay, the CPU pretty much, once it's booted, it sits there and waits for something to happen. How do you let the CPU know something has happened on the computer system? Okay, please post your responses. Okay, input devices, wires. You're communicating with the CPU when you touch your touch screen. Okay, when you try to download something from the internet, that uses your CPU. When you get a notification, if you have notifications turned on your phone, that lets the CPU know an event has occurred. When something's loaded from a hard drive, that's an event that occurs that the CPU needs to know about. Okay, so you all have an idea of, once the computer's booted, how does these different things let the CPU know that an event has occurred and that we want the event to do something. But what really happens is an interrupt happens. An operating system is interrupt driven. Every time you touch your touch screen, every time you press a key on the keyboard, an interrupt is sent to the CPU that interrupts its operation and says, hey, you might need to do something else right now. Check to see what's going on. Okay? So we're here with on our computers, interrupts are happening to the CPU all the time, and it happens so fast that you don't even really know that it's happening, okay? So usually an interrupt will transfer control to the interrupt service routine through an interrupt vector. That interrupt vector will service that interrupt, do whatever it needs to. Sometimes it says, okay, I'll deal with this later and carry on with what it's doing. And then it will return to the program that was executing when the interrupt occurred. Okay, so what you're going to see is that when these interrupts occur, even though what you're working on has been interrupted, you're not even going to notice the difference usually, unless there's some kind of problem. You can also cause interrupts. When you're programming, if any of you work in programming languages, you can cause software errors that cause a trap or an exception to occur. And if you programmed in a language like Java, you may remember things like doing exception handling in your code, so that if someone does a divide by zero, for example, which is a software-generated error, an interrupt would be generated at that point, and your program can actually trap that exception, or catch that exception. It's called try and catch in Java. Catch that exception and do something about it. So interrupts are used constantly throughout the system. Okay. Here's another view of an operating system, and like I said, the first couple chapters of the book, that's what they do. They give you lots of views of computer systems, of operating systems. And here you can see that we have, one or more CPUs, and there's a different device controllers for the different devices, and they're all connected to a common bus. So we have devices, we have the CPU and the controllers for the devices, we have the bus, and they're all trying to access memory. Okay, so we have a lot of contention on the system. The CPU and the devices are contending for system resources. So a big part of what the operating system does is manage all this contention. Who gets the resource next? When we talk about main memory, since everybody seems to want it, we talk about main storage and secondary storage. Registers, cache, main memory, and solid state are usually what is called are usually called, just up to main memory, registers, cache, and main memory are usually what is called volatile memory. That means that when the power goes out, you lose anything that is in those registers, cache, or main memory. Everything from solid state and below is non-volatile. So that's where things are stored more permanently. Registers, cache, memory, and solid state disk are all implemented usually in semiconductors, whereas the other things are like your hard drives, your optical disk, your magnetic tapes. They are actually slower devices. In order for a program to be executed, the programs must be in main memory, and the data that they're using, the data that they're manipulating, also must be in main memory. So that's why there's so much contention between the different devices and the users on the computer system. Okay, one of the things, since things out on disk are slow, things in main memory are slower than cache, caching is done so that some information is temporarily copied from slower to faster storage. And you may have heard the term caching used in a lot of different areas. Sometimes caching refers to this type of caching where it's moving things into your fast storage areas. Other times they're talking about having things in memory, like sometimes your pages are cached by your browser. Okay, that means it's keeping them. It's not actually going out to the internet to get a page the next time you go to it. If you've already looked at that page before, it just goes to the one that's already in cache. And you might have seen where sometimes things on the web get updated, and if you have an old page in cache, you keep seeing the old information rather than the new, unless you reset your browser or clear your cache or something like that. Okay, so we will be talking a lot about memory and memory management in the course. Are there any questions in what we've talked about so far? Okay. Your book also goes into a lot of information on computer system design. You may have, looked at things about single processor systems in which, you only have one processor in your phone or in your computer, your laptop. And, many of us are very happy with that because they're also single user systems. So pretty much anything the processor is doing, it's because we want it to do that. So we're pretty happy with that. The other type of system design you might see is multiprocessor systems. And this is when there's actually more than one CPU in a system, and they have different relationships between symmetric and asymmetric. If you have a multiprocessor system that's symmetric, it means that all the processors are equals, and the I/O can be processed by any of the CPUs. Asymmetric processing means there's one master and the rest of the CPUs are slaves. So there's one CPU that's kind of handling everything, and the other ones are waiting for the main CPU to tell it what to do. This can be a parallel system situation, and we will be talking about parallel systems. Your book already talked a little bit about threads, and that's when you have multiple things executing in parallel, and you have to be aware of situations like deadlocks and so forth, which we will be talking about in more detail in the course. Okay, we also have clusters, and clusters differ slightly from multiprocessor systems, but in this case, usually all the systems are working together. In other words, one task is being divided between these different systems, rather than discrete tasks being given to different computer systems. Okay, another term that's important is multi-program systems. Back in the old days, a computer ran one program, one job, one thing at a time. Now, even if I'm on a single processor system, I can do multi-programming. There was a question, let me go back to the previous slide just for a second. Monterey is asking, what's the difference between symmetric and asymmetric? Symmetric is when all the processors are peers. Okay? They all have an equal chance of working on whatever I/O requests or whatever come in. With asymmetric, there's one processor that's the master and the rest are slaves. The slave processors don't do anything unless the master processor tells it to. Does that clear it up for you? Okay. All right, so like I was saying, in a multi-program system, even if there's just one CPU, there can be multiple jobs running on the system. And this was actually a big breakthrough in computer systems when they figured out how to do this, because it's very important that we keep the CPU busy all the time. One of the things that you might realize is the CPUs process things a lot faster than we can type, or even that things can be read from disk or whatever. So it's important to keep the CPU busy. So what they do is or what you do in an operating system is you actually have different jobs loaded in the CPU or in memory so that the CPU can be executing job 1, and let's say job 1 needs something off the disk. Well, the CPU knows that that's going to take some time, so it may switch to job 2 and start doing that until it needs to pause for whatever reason, and it'll switch to job 3. This is also related to the concept of time sharing on a system. And this is where you have multiple users on a system, but each user kind of sees the system as if they have the whole system to themselves. I mean, it does slow down at times, but that even happens when only one user is on a system. And what happens is each user on the system is given a slice of time when its particular processes are running. But it happens fast enough that you feel like you have a dedicated system. Okay. I kind of already addressed the next question. Why would a single user want a multi-programming system? And I'm not going to really wait for you to respond on this one because we've already talked about it a little bit. You want to keep the CPU busy. In other words, you want to be able to be chatting with your friends. Muna has it exactly right. You want to be able to chat with your friends while you're downloading some music, while you're surfing the web, all the different things that you're doing. Plus, if you've ever looked on your system to look at the processes, I don't know, like on a Windows system, you do, Control-Alt-Delete, or you go out to I can't remember what the task is, that will show you all the processes that are running, and you look out there and you see all these different things that are running on your system, most of which you don't even know what they are. In some cases, they're operating system functions. Sometimes they're viruses, and you have to watch out for those. But then you'll see things like your browser running, and you can see how it's taking different amounts of CPU and so forth, even though there's only one person working on your system. Okay, we already talked a little bit about how the system is interrupt-driven, and it's interrupt-driven by the hardware, and there are also exceptions and traps that you might generate as you're running programs. But the system also has what's called dual mode. You don't want everyone to have access to what are called privileged instructions in the operating system. So some things are run in user mode, which means they're pretty safe. Other things are run in kernel mode, which means only very specific things can get down into that low level of the operating system and run. Okay, that's for protection. And so you might be running a user program. You need to do something deep in the operating system. Through a controlled series of calls, you'll move from user mode to kernel mode. Okay, and back again. You don't see any of this, but it's a way that the system protects itself. There's also memory protection, so that if more than one person or more than one program is running, they don't trash each other's memory. Okay, and there's also timers built into the system so that if something's looping, it won't necessarily run forever. Sometimes the CPU will detect that something's hogging a lot of the time, and it will abort the process that's running too long. And your book goes into quite a bit of detail on all of these. Okay, so what you've seen then is that your system is doing a lot of management and control. Hala says you can kill the process if something's looping, and yeah, sometimes you can, although I've had things happen on my system where the only thing I could do was power down. I couldn't even get an interrupt into the operating system to try to kill the process. I actually had to shut down my system. But I try not to get in those situations, and sometimes I don't even know what causes it. We can talk a little bit about these. I don't want to go into a lot of detail because your book goes into the details on this, but we do have all these different management and control features in our system. There is process management, and that's where we're doing the operating system. When I say we, I'm actually talking about us as operating system programmers. We're creating and deleting processes, we're suspending processes, we're providing the mechanisms for the processes to sync up, and so forth. We also have different memory management where we're making sure all the instructions and all the data's in memory when a program needs it, as well as keeping track of who's using what parts of memory and those types of things. Storage management is the way that we're getting through the different devices. We're getting through all the different layers of the operating system to the different devices and getting things off the hard drive. This includes storage management both inside the computer and your mass storage like your hard drives. And then there's also security and protection, which is another thing that we'll be talking about in this course, where we want to control access to processes or to resources on the system, and then security, we want to defend the system from attack. And your book talks about those. All of these topics we'll be looking at in more detail as we continue through the course. You're also going to see references to different data structures. I'm hoping most of you are familiar with data structures like a singly linked list, like a doubly linked list, a circular list, a binary tree, a hash map along with hash functions, and bitmaps. These are the type of data structures that are used in a kernel to help keep track of all these things it needs to keep track of. Okay, so I don't have time to discuss all of these. Hopefully you're familiar with them. If you do have questions about what any of these are and you don't have a resource that you can find on the web that you can understand, feel free to email me and I'll try to explain them to you. Okay, your book also goes through a number of computing environments. The traditional environment that we're used to with our PCs and our laptops, the mobile environment like our cell phones, a distributed environment where, again, you're looking at having things on multiple computers that are connected together using TCP/IP through a local area network or a wide area network or something like that. We have client-server systems where there's a server and then just dumb clients. They're not even PCs. They're just terminals that are connected to a server. We have peer-to-peer environments where everything's connected to everything. And then we have things like virtualization environments where, for instance, if I have a Mac computer, I can run a Windows environment on my Mac so that I could run things like Microsoft Word and so forth, and that's called virtualization. We're all getting into cloud computing environments. You know, you might save the things from your smartphone on the cloud for example, or use the Google Cloud or the Amazon Cloud. So in that case, you're doing cloud computing where the resources you're using aren't even anywhere near you. It's somewhere up in the cloud. And then, of course, there are embedded computing environments, which you actually use all the time and probably don't think about. When you use your microwave or your car, you turn on your car or that type of thing, those all have computers inside them, and that is an embedded computing environment. Okay, we are running out of time for today. I'm going to stop at this point and see if there are any questions that I can answer. And if not, I will pick up from this point in the discussion when we meet next time. I'm also going to try to, while you're writing any questions or any comments you might have, I'm going through our list here so I could mark that you were present in the course. And it's just going to take me a minute or two. So, even if you go off and do something else, don't log out until I'll put up a message when I've recorded all the attendance, just so I make sure you get credit for being here. Hello, Sarah. I was just taking attendance, and we're finishing up for the day. Just stay logged in. I will post a chat comment when I've taken attendance, and that way I can make sure everyone has gotten credit for being here today. Mona asked if I will upload these slides. Yes, I will be getting those to you after this course. I mean, after I'm out of this session and I've updated my attendance. Most of these slides were already in the PowerPoint that was provided to you. I'm just thinking about it now. If you do want to get out of the session, you can do so. I can always go back in the recording and look to see if I'm missing somebody if they had attended the session. Okay, you all can leave now. I have taken the attendance. Thank you.